So welcome everybody. We are talking about permutations and combinations, and specifically today's lesson is on more difficult combinations. We're mostly going to be doing combinations, but combinations are where order does not matter. Permutations is where order matters. If I have 24 people in this room right now, and we want to do combinations of 5, I'd like you to figure out how many combinations of 5 there would be. That's 24. C5. Now that can be done with factorials or with your calculator or with your calculator and factorials or with your calculator and the C button. Do you know where the C button is? Alright, so let me tell you the factorial way first. Do you get that this would be 24 factorial over 24 minus 5, which would be 19 factorial, times C, there's an extra 5 in it. 5 factorial. Remember that way? That formula is something you're going to need to know. Do you get that? This number came from 24 minus 5, and there's an extra one of these over here. All right, but there's a much faster way. Everybody clear your calculator. Get the calculator cleared off, and then type in just a 24. And then we have to type the C function, and I'll show you where it is. 24C5 is what we want, right? How do you get a C in there? It's under Math, and then PRB for probability. Math, PRB. You arrow to the right until you get to PRB, and then it's the one that says NCR on it. I'm going to pause for a second while I pull that. So here it is from the top. If I want 24C5, I'm typing in 24. And then to get the C, I go to Math, arrow over to Probability. Most people's calculator just says PRB on it. I've got the fancy operating system where it goes a little further. Prob. Anyway, and then I arrow down to C, NCR. Hit Enter. Now it says 24C, and then it wants to know what's the other number. 24C5. And I hit Enter. And 24C5 is 42,504 different teams I could bring just out of this classroom. 42,000, it does not seem possible. Yet, probability is something that doesn't just come naturally to our brains. This is why casino owners can abuse people so easily. Because people really don't get probabilities. They think they do, and then they really don't. They think that they're likely to win, and then they're not. So anyway, the probabilities can be used against you. Be careful. All right, 24C5 was 42,504. Do you think if I did 24P5 that it would be more or less? Why would it be more? Make your argument it'd be more. So he's saying because the order matters. You might have as many as like 20 times or 25 times as many. Because if I pull out 5 people, then there might be 5 different combinations of them. If you rearrange them all. All right. So I think it's actually, well, we could actually figure it out, but let's do it. 24P5. Everybody type it in. 24P. It's under Math. Probability. P, NPR. Specifically, it's 5 million different combos now, and that's if we rank order the people on the team. Like, you're going to be our first place guy, you're going to be our second place guy. That actually does happen on teams. Think about the tennis team, for example. If they're on the tennis team, they do have their number 1 player, and then their number 1 player plays against the other team's number 1 player. And so they do rank people. That's the world is. So our culture doesn't rank people near as much as a lot of other cultures do. In Japan, for example, everybody knows the rank order of the college. The number 1 college is this certain college, and the number 2 college is that college, and the number 3 college is that college. It is just ranked like that, and you get a ranking when you're done with your school. You are number whatever, and then if you aren't a high enough rank, you can't go to the number 1 college. They can only send so many people there. So if you're the number 1 person, you get to go to the number 1 college. Anyway, so we are less rank obsessed than some cultures. I hear China is getting more and more like Japan that way, where there's a rank order and you like work your butt off to try to get into that best school, because if you don't get into that school, you have no chance of ever becoming a doctor or a lawyer, because only this school in all of China produces them or whatever. Obviously, it wouldn't just be one school because they have a massive country, billions of people, so they're going to have a couple schools. But the point is, rank is actually super important in some places. Well, anyway, this was ranked. P was ranked. There's a lot more combos with ranked. All right, let's talk about today's assignment. I actually want to teach today's and tomorrow's because some of you guys are not going to be here tomorrow because of AP testing. How many of you are taking an AP test tomorrow? All right, 4, 5, 6, 7, 8, 9, 10, let's go. All right, that is not everybody, but that is many of you. Okay. Calm. I'm happy you're going to be back. Many of you are going to be back, but there are still other people that are going to be gone. There's other things that are going on. So my point is, I need to teach you more than what's on this slide. So I'm going to make up some that are going to be good for you to understand to handle today's and tomorrow. All right? Here's the topic. We are doing CC over C. I know that doesn't make any sense to you right this second, but if you want a probability that has subgroups in it, then you need to have CC over C. Some of you are not paying attention. I need you with me, 100%. All right. So let me show you an example. For this classroom right here, I'm going to count up how many males and females we have. 1 year I counted wrong. Very embarrassing. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. I'm counting me in here. 15 males. And now females. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 females. That does add up to 24. Okay. Yes. So, we have 24 total, right? Now, let's do that same kind of a problem where we're going to take a group of people out of the 24 here. Again, this is a total 24. We're going to pick out just two people that get to go on, I don't know, some special award trip. Okay? So, out of 24, everybody fill this in for me, please. 24 total, 2 get to go. What I just did there is I found all the possible combos of 2 people chosen from 24. Do you get that this is a probability because it's a big divide? So this is what's possible on the bottom. What I want is on the top. Now, let's say I said, I want to know the probability that I'm going to randomly pick 2 people at the bottom, but I want it to turn out to be 1 guy and 1 girl. Well, then you say, this is the male, this is the female. I want it to be 1 guy who can do this easily. Not hard. 15C1 and 1 female. 9C1. There is your formula that masters the hardest probability. It's not that scary. It really isn't. Let me show you. This number, triangle, triangle, triangle. Do you get that they all add up? 15 and the 9 has to add up to 24. This is our totals on the bottom, right? And 1 and the 1 adds up to 2. Okay. So I have almost never marked one of these wrong if the kid did what I just did and checked to see that their numbers actually add up to the thing on the bottom. Because when people set them up wrong, they set them up so they don't add up. And then they usually, if they check themselves, realize, oh, wait a minute, that isn't adding up. If you don't check yourself, you just blindly put them in the calculator and you think your answer is right. Okay, let's change this to cookies. Anytime you can make subgroups within the big group, you can use this method. Here's about cookies now. It's going to be 20 cookies. There's going to be 4 peanut butter. Oh, I love the peanut butter one. There's going to be 12 oatmeal. I don't like those as much, but. And there's going to be 4 chocolate chips. See if you can use the CC over C thing to figure out for me. Given I choose randomly from these 20 cookies, what's the probability that if I take 3 cookies, that I get 1 of each? It's not that hard. CCC over C. It is a valid point. I was saying CC over C, but in this case, there's 3 subgroups, so we have to have CCC over C. All right. Mr. M in the corner. An M on your hat. So, what's the bottom? That's the easiest part. How is the place you should start? There's what, and I'm choosing what? 20 cookies, choosing 3. Subgroups on the top, Mr. Y. You're doing peanut butter here, oatmeal here, and chocolate chip here. You could have done it in any order, but I'm assuming this. Okay, so peanut butter, C, it's going. 12C, and 4C1. That's it. Now, if you're smarter than the average bear, you went back and added those up and made sure they added up to that. And then you went back and made sure that that plus that plus that added up to that. And if you do that, I'm telling you, you could still get it wrong, but it's much less likely. All right. Now that you know where the P and the C button are on your calculator, you get how you just have to multiply these all together. That times that times that. And then why do I divide? Because it's probability. You got to divide by all the things that were possible. These are all the things that could have happened when we chose 3 cookies. Let's actually figure this one out. What is it? 168. Can I round it to 17%? Somebody else has verified that for me. Awesome. So this is 17% chance. Now, just gut feeling. Do you get it? It's not likely that you get that lucky. That if you've got 3 random cookies, you get 1 of each. Pretty unlikely. And it's, in fact, 17% chance. All right. Imagine for a moment that we've got freshmen, sophomores, and juniors in this big group. I'm just going to leave the seniors out of this one to make it simpler. Freshmen, sophomores, and juniors. 3 freshmen. There's 8 softs and 1 junior. So that's 8, 9, 10, 11, 12 people. Okay? They get to pick half of their people, as in 6. They get to pick 6 people out of the group that get to go on this reward trip. Like in Survivor, their team wins, then not everybody gets to go on the reward, and they have to pick people, and it's really painful because some people get to go on these amazing, like life-changing experiences, going to like swim with turtles in the Caribbean or whatever, and they don't, anyway, there are some pretty cool ones. So there's, why can't I just say 12 C? How many are going on the trip? 6. Why can't I just say 12 C6? Well, that's how many possible groups there are. That's all the possibilities. Now I'm going to change it into a probability. What's the probability that it's going to be only sophomores and juniors who end up going, and the freshmen get left out? You can do this. CCC. And you might be saying, well, what about those freshmen get 0? Well, yeah, you just say 0. 3, choose 0 for the freshmen. And how about the softs? 8, choose. How did you know it was going to be 5? Because there's that one junior who has to go to make it be sophomores and juniors. So 1 junior, choose 1. These get multiplied. Final answer. You multiply the top, you divide by 12C6. I got the answer already? All right, I know it takes a while to get these. That's okay if you just get that idea. All right, that's today and tomorrow. Now here's the good news. Today, all they ask is for the top. They never even ask for a probability. What makes it a probability is that you have to divide by how many were possible. So your answers will be just like this today, except you won't have to do this part. All right, now your assignment was, it's kind of on the long side. So everybody, please find it right now, and I'll tell you which ones you can skip. Okay, problem 3 is the one you can skip. It's got lots of parts. That'll save you a bunch of time. Okay, so skip problem 3, do the other one. And a typical problem will ask you something like this. There are 5 kinds of meat. Oh, you can choose. Okay, and that's all you have. It'll just be the top. It'll be like the CCC. It'll just be the tops. You're doing all the problems except problem number 3. That's all I have for you for today. Have a good day.